Determine if two symbolic statements are equivalent using a truth table. Now, if we're talking about being logically equivalent, that means the truth values match. So if we're looking at a truth table and I have true, false, and then the next one is true, false, then yes, check it off. These are logically equivalent because the truth values all match, going across column to column. Okay, so let's use a truth table to determine if any of the following statements are logically equivalent. All right, so we're going to compare these three statements to see if they have the same truth values. Now, you'll notice we just have P and Q. So because there's just two, we're just going to have 4 lines. True, true, false, false. The second one we cut in half and do true, false, to create 4 distinct sets of 2. Now, you're also going to notice that we have not P and not Q. So let's go ahead and make a not P and a not Q column. Remember, negation simply takes the opposite truth value. So if I have a column P, true, true, false, false, as you see here, not P would then be false, false, true, true. Works the same for negating Q. If Q is true, false, we're going to do false, true, false, true. Now we've got our basics. Now we're ready to put these together in terms of pieces here. So let's do if P, then Q. This is our first one. Now we have a conditional. And in case you've forgotten, a conditional is only false when the front end, that's P, is true, but the back end, that's Q, is false. It's the only time a conditional is false. So when P is true, that's these two, and the back end is false, that's here. This spot right here is the only spot the conditional is going to be false. Every other spot is going to be true. So with the conditional, front end is true, back end is false. This is the only time that's going to be false. All right, now let's look at the next one. So now we have the second one, P or not Q. Remember, the symbol for or is the V, and or means one of these has to be true for the entire statement to be true. So I'm looking at P, not Q. Okay, so true, false. That's true. True, true. Well, that's true. False, true. Oh, wrong one. False, false. I looked at the wrong column. False, false is false, and false, true is true. Okay, now comparing these two, 1 and 2, these are not logically equivalent because I have trues, then a false true here, not logically equivalent. So I know 1 and 2 don't work. All right, let's go ahead and go to number 3. Number 3 is not P or Q. So now I'm looking at not P or Q. And again, this is an or, so one of them has to be true. So I've got false and true, that's true. I have false and false, that's false. I have true and true, it's true. And true and false is true. Okay, now let's compare. I have trues at the top, then I have a false, then I have a true, and a true, and a true, and a true. Oh my gosh, if we look at 1 and 3, you will see that they are equivalent because of the truth values, right? They work all the way down. So we could say if P then Q is logically equivalent to not P or Q. And that's how we know because of the truth table.